Hi, how are you? I missed you. You have done well during the first term. I hope you have done each one alone, not group work. It seems that to me that you have done your test by group. The same mistakes, same parts are not solved. So I don't know. Please next time try to do by yourself. Remember that you have official exams this year, so you are not going to copy from each other. So depend on yourself next time. Okay, in this video we are going to correct the first exercise. So the first exercise في شوية part 7 and 8 are not done by all of you, and some parts in the economical part. So let's start correcting the first exercise. So first exercise, part A, we have the function defined over minus infinity minus 1 union minus 1 plus infinity by fx equals x squared plus x plus 4 over x plus 1. And we have C is its curve in an orthonormal system. Calculate the limits of f at the open bounds. Limits of f at the open bounds of the domain. So this is the domain here. In this here we have two open boundaries, which are minus infinity minus 1. And here we are going to command, we have two open boundaries, minus 1 plus and plus infinity. So you are going to determine 4 limits, and after determining the 4 limits, you are going to deduce an asymptote. So 4 limits, then deducing an asymptote. So limit as x tends to minus infinity of fx, demand always at minus infinity of a rational function. We take the highest degree in the numerator. The highest degree in the numerator is x squared, and the highest degree in the denominator is x. So we take the limit of the highest power over the highest power. So it will be x squared over x. X squared and x are simplified, so we don't replace directly. We simplify first. We get x, and as x tends to minus infinity, we get minus infinity. Also limit as x tends to plus infinity of fx. By the same way, it is limit as x tends to plus infinity of highest power over highest power, x squared over x. Once again, we simplify x squared to x remains x, you get plus infinity. Here in the domain, you have minus 1 here and minus 1 here. So we are going to determine limit as x tends to minus 1 minus and x tends to minus 1 plus. So limit as x tends to minus 1 minus of fx. Minus 1, we replace x by minus 1 in the numerator. Minus 1 squared is 1. 1 minus 1 is 0. We get 0 plus 4, 4. تحت minus 1 plus 1 is 0. And as x tends to minus 1 minus, it will be 0 minus. So it will be 4 over 0 minus. Number over 0 is minus infinity. And the limit as x tends to minus 1 plus of fx equals. Also, if we replace x by minus 1, we get 4 in the numerator, and 0 plus, since it's minus 1 plus, equal plus infinity. So we are going to deduce an asymptote. First, limits x tends to minus infinity gives minus infinity, and x tends to plus infinity, y tends to plus infinity, or fx tends to plus infinity. We don't have an asymptote. But here, x tends to a number minus 1, y tends to infinity, so x equal minus 1 is a vertical asymptote. Okay, we are asked to deduce and there is only one asymptote, which is x equal minus 1. Verify that f prime x equals this form x minus 1, x plus 1, x minus 1 into x plus 3 over x plus 1 square. As you notice here, fx, it is of the form u over v. U is x squared plus x plus 4. U prime, derivative of x squared plus x plus 4 is 2x plus 1. And v prime, derivative of x plus 1 is 1. So u على v, derivative of u على v is u prime v. So rule for the quotient, derivative of the quotient is u prime v minus v prime u over v squared. U prime is equal to x plus 1. V is x plus 1. V prime, derivative of x plus 1 is 1 into v into u of 1, x squared plus x plus 4 over v squared, which is x plus 1 squared. You expand 2x times 2x, we get 2x squared, 2x times 1 is 2x, 1 times x is x, 1 times 1 is 1, minus x squared, minus 1 times x, we have to change the signs, minus x, minus 4. 2x squared minus x squared, by simplifying, we get x squared. X minus x, 0, we get 2x. 1 minus 4 is minus 3. Over x plus 1 squared, we get, if we expand x minus 1 into x plus 3, we get x squared plus 2x minus 3. It will be x minus 1 over x into x plus 3 over x plus 1 squared. Some of you بعرف شو طلع معهم هون الانسر، طلع معهم يمكن x squared plus 3x minus 3 دغري حطوا الريزلت هيك. Check يعني expand first x times x squared etc. Check if this one equal x minus 1 into x plus 3. So we have half point for this part for the derivative, while in the first part the limits and the asymptote we have 1 point. Set up the table of variations. Set up the table of variations of f. To set up the table of variations of f, we have to study the sign of the derivative. Studying the sign of the derivative. How to study the sign of the derivative? So we solve f prime x equal to 0. F prime equal to 0, then x minus 1. Here we take the numerator, x minus 1 into x plus 3 equal to 0. X minus 1 equal to 0, it means that x equal 1. X plus 3 equal to 0, it means that x equal minus 3. 1 and minus 3, all of them belong to the domain, so they are both accepted values. Table of variation, we put x, f prime x, fx. Domain of definition first, minus infinity, minus 1. We put a bridge at minus 1 and plus infinity. The values of x are, we get here minus 3 and 1. The values of x are minus 3 and 1. Since it is of the second degree, between the roots, opposite sign as a, so between the roots it is negative, and outside the roots will be positive. Second degree, or we can take a numerical value. For example, if we take x equal 2, here, we replace it in the derivative, we get 4 plus 4, 8, minus 3, 5, positive here. 0 changes the sign, and here is positive. Positive, increasing, negative decreasing, negative decreasing, positive increasing. At minus infinity, we get the limit minus infinity. At minus 1 minus, we get minus infinity. At minus 1 plus, we get plus infinity. And at plus infinity, we get plus infinity. To calculate the maximum and the minimum at x equal 1, f of 1 equal 1 plus 1 plus 4 over 1 plus 1, 6 over 2, we get 3. I put 3 here also in the table. The maximum is equal f of minus 3. F of minus 3 is 9 minus 3 plus 4 over minus 3 plus 1. It will be 10 over minus 2 equal minus 5. Then the maximum is minus 5. I put minus 5 here. This table of variation is half point. Show that fx equals x plus 4 over x plus 1. And some of you, they take ax plus b, etc. They take fx equals ax plus b plus c over x plus 1. It is okay, but we can solve it by an easy way. So we can take the common denominator here. Simply, we take the common denominator on the right side. So by taking the common denominator here on the right side, the common denominator is x plus 1. X times x is x squared. X times 1 is x plus 4 over x plus 1. This one is fx. This is fx here. X squared plus x plus 4. Here it is x squared plus x plus 4, which is verified. So 1 over 4 point. It is not difficult. Show that the line D of equation y equals x is an oblique asymptote to C. To prove oblique asymptote, we should prove that the limit as x tends to plus or minus infinity of fx minus yd equal to 0. Limit as x tends to plus or minus infinity of fx minus yd equal to 0. So here, fx minus yd. So it is better, since you are told in part A to show fx, this one. So it is better to use this fx. It is better. So fx minus yd, this is fx that we have proved it in part A, minus yd, which is minus x. X minus x, 0 remains 4 over x plus 1. And limit as x tends to plus infinity, we remove the limit and we put instead of x plus or minus infinity. So 4 over infinity is 0. 4 over infinity is 0. Then the line dy equal x is an oblique asymptote to C. This is also half point. Now, position, I think, C, study the relative positions of C and D. To study the relative positions of C and D, we have to study the sign of fx minus yd. Sign of fx minus yd. Fx minus yd is 4 over x plus 1. The numerator is positive, so I take the domain x plus 1 different from 0, x different from minus 1. This is the domain of definition, minus infinity plus infinity. If I need to know the sign, After -1, I take a number greater than -1, like 0, 4 over 0 plus 1, we get 4 over 1, which is positive. Negative here. Negative in C is below D. Positive C is above D. You have to write C is below, no, not writing below and above. Which one is below and which one is above? You have to write C is below D and C is above D. Some of you have written below D, below above. Not correct. Show that the point I -1 is a center of symmetry for C. We have the rule of center of symmetry, which is f of 2a minus x, f of 2a minus x plus fx equal to b. This is the rule, f into 2a minus x plus fx equal to b. A, this is a, which is -1. -1 times 2, we get -2 minus x plus fx 2b, b is -1, we get -2. بس البريفيوس بارت عليه 3/4 وهذا البارت عليه كمان 3/4. So fx is given by this one. This is fx given. F of -2 minus x, we replace each x by -2 minus x. This x, we replace it by -2 minus x plus 4. This x also, we replace it by -2 minus x plus 1. We get -2 minus x plus 4. -2 plus 1 is -1 here, minus x. So I can put it -2 minus x by multiplying by negative the numerator and the denominator. It becomes -4, this one, over x plus 1. Now, f into 2a minus x plus fx. We have calculated f of 2a minus x. This is f of 2a minus x. This is f of x. X minus x, 0. -4 over x plus 1 and 4 over x plus 1 is 0. We get -2, which is equals 2b. Part 6. Draw C and D. To draw C and D, so line D of equation y equal x, line D of equation y equal x. To draw this line, for x equal to 0, y equal to 0, this is, for x equal 1, y equal 1. So this is the oblique asymptote. Now, I draw the vertical asymptote, which is x equal -1. This is the vertical asymptote, x equal -1. Then we locate the minimum and the maximum points. The maximum occurs at -3, -5. This is -3, -5 here. The minimum occurs at the point 1, 3. So this is 1, 3. You can use the calculator and taking particular points using the calculator. إذا الx 0 بتعطينا y 4. So according to the table of variation, the curve is increasing -∞ to the maximum. This is -∞ near the oblique asymptote to the maximum. It increases to the maximum. Then it decreases near the vertical asymptote. We get this part. It is cut at x equal -1. The second part, -1 plus infinity. This is -1 plus infinity here. It decreases to the minimum, then it goes to plus infinity near the oblique asymptote. Now, the line D of equation y equal 4. Find the coordinates of the point of intersection between C and D. Find the coordinates of the points of intersection between C and D. To find the intersection, we put y equal y. I don't know why all of you have done this part false. So y equal 4, y equal y, not x here, y equal 4, this should be 4, x squared plus x plus 4 over x plus 1 equal 4. I put it 4 over 1, cross multiplication, x squared plus x plus 4 times 1 remains x squared plus x plus 4. 4 times x is 4x plus 4. We bring them to one side, x squared plus x plus minus 4x equal 4 minus 4, which is 0. The x squared minus 3x equal to 0. So x equal to 0 or x equal 3. So this line cuts this line y equal 4. This is the line y equal 4. Cuts the curve in 2 points, x equals 0 and x equals 3. انتوا بتشوفوا هون بتلاحظوا it cuts the curve at 2 points. هلا solve the equation 4 minus fx greater than 0. I can solve it by 2 ways, either graphically or by calculation. 4 minus fx greater than or equal to 0. I can put it like that. 4 fx less than or equal to 4 minus fx. I take 4 to the next side, it becomes minus 4. Since we have minus here, I multiply by minus the two sides. Fx less than 4. It means that C is below the line D. C is below the line D. This is the line D. C is below the line D. This part is below the line D from minus infinity till minus 1. And this part from 0 to 3. From minus infinity to minus 1. Then from 0 to 3. So graphically, we solve this one graphically. The curve is below the line D, header line D, y equal 4, capital D, y equal 4, from minus infinity till minus 1, and from 0 to 3. Minus infinity, it is opened, أكيد, minus 1, it is opened. I close them at 0 because I need greater or equal. إذا ما في equal, they will be opened at 0 and 3, but since we have equal, we close the interval at 0 and 3. Now we go to the economic part. A factory produces a quantity X of motors, where X is expressed in thousands, X expressed in thousands of items. X should be positive, sure, X could be positive. The quantity cannot be negative. The total cost is given by Cx equals x cubed plus x squared plus 4x, where Cx is expressed in millions of Lebanese lira. Cx is expressed in millions of Lebanese lira. Part 1. Calculate the total cost for producing 1,000 motors. Calculate the total cost. We are going to calculate the cost. We are going to calculate C. So we replace X by 1. Why by 1? Because it is in thousands. So 1,000 motors, X equal 1,000 divided by 1,000, which is equal to 1. C of 1 equal 3. If we write 3 without the unit, it is not correct. So 3 millions of Lebanese lira. So we have to write also the cost of production of 1,000 motors is 3 millions of Lebanese lira. half point. Show that the average cost is equal to fx. Show that the average cost is equal to fx. The average cost is given by the rule. Average cost, C bar of x, is denoted by C bar equal Cx over x. This is Cx, x cubed plus x squared plus 4x over x plus 1 over x. بتضل هذه x هون. So this is Cx over x. I take x common from the numerator, x into x squared plus x plus 4 over x into x plus 1. x and x simplified. بضل في عندي x squared plus x plus 4 over x plus 1, which is equal to fx. So the average cost equal to the total cost over x, يعني Cx over x. Find the number of items that should be sold. Find the number of items that should be sold so that the average cost is minimum. And determine the average minimum cost. The average minimum cost. Since C bar is equal to fx, to find the minimum of the average cost, we have to find the minimum of fx. The minimum of fx لقينا قبل شوي from the table, لقينا at x equal to 1. So C bar is minimum, and since C bar is equal to f, so f is minimum. So for x equal 1,000 of motors, x here 1,000 of motor, and the minimum average cost is 3 millions, and the average minimum cost is 3 millions of Lebanese lira. Knowing that each item had its selling price is 5,000 Lebanese lira for each motor, and 80% of the production is sold. Only 80% of the production is sold. Not all the production, 80%. Show that the revenue function Rx equals 4x. Revenue function equals 4x. We know that the rule for the revenue equals price, selling price over the unit of the price times x times the unit of the quantity times 80%. إذا قلنا all the quantity is sold, I don't write anything here. But if he said that 80%, I multiply by 80% of the production, 80 over 100. Selling price is 5,000. Unit for the price is the millions. X is the quantity. Unit is in thousands. 80 over 100. 6 zeros. 1, 2, 3, 4, 5, 6. بيروحوا مع 6 zeros هون. وهون 0 مع 0 بيروح كمان. 5 times 0.8 or 5 times 8 over 10, we get 4x. The revenue is 4x. Verify that the profit function is given by, the profit is given by px equal x into 4 minus f of x. You know that the profit is equal to the revenue minus the cost. The revenue already is determined for x. الcost هو x. We know, you know that the average cost here from here لقينا that the average cost equals cx over x. So the cost equal x times c bar in x times fx. So revenue minus the cost, the revenue is 4x. This is the cost. If I take x common from the numerator, it's here x into x squared plus x plus 4 over x plus 1. This one is fx, 4x minus x times fx. I take x common, remains 4 minus fx. So the profit equal revenue minus cost. Determine the level of production to get a break even. To get a break even, يعني the profit is 0. يعني x into 4 minus fx equal to 0. It means that x equal to 0 or fx equal 4. fx equal 4 نحن جايبينه من home from part 7. So break even profit is 0. يعني x into 4 minus fx equal to 0. To solve a product equal to 0, we say x equal to 0, which is rejected. لأنه قايلنا بالdomain here. إذا شايفين x is positive. X is positive. So x equals 0 rejected. 4 minus fx equal to 0. يعني fx equals 4. لقينا fx equal 4 from previous part here. Fx equal 4. We get fx equal 4 from here. X equals 0, x equals 3. X equals 0 and x equals 3. So here x equals 0 and x equals 3. هذا not 1. So هذه غلط. X equal to 0 or x equal 3. So for a production of 1,000 items or 3,000 items, we get a break even. So but for a production of 3,000 items, we get a break even. هذه not correct. هذه هون not correct, this sentence. So for a production of 3,000 items, we get a break even. And finally, for what quantity the factory will achieve a profit? The factory will achieve a profit if the factory will achieve a profit if px positive, meaning 4 minus fx is positive. 4 minus x is positive. يعني fx is less than 4, not 0 هيدي. fx here will be less than 4. Graphically لقينا نحن fx less than 4 من هذا البارت هون. fx less than 4 من هذا الاكسرسايز هون. fx less than 4 الاكس بتكون between 0 and 3, not 1. Should be between 0 and 3. So for a production between 0 and 3,000 items, the factory will achieve a profit. This is not 1, it will be 0. So for a production between 0 and 3,000 items, the factory will achieve a profit. Okay, this is all for the first exercise. I will send another video for the other exercise.